There we go. Okay, so let's start with a little quiz, right? Who said this phrase? Autonomous vehicles are very simple and cheap to develop. Self-driving tech is not worth it. So, who said that? Nobody ever. So that's not the point of this. If you think autonomous vehicles development is easy, you are in the wrong presentation altogether, right? It's not easy. The real question is, how can we increase the brain power and optimize the efforts applied to one of the hardest problems in tech nowadays? It's one of the hardest, one with potentially the highest yield of benefits to society in general, depending on who you talk to, but by far and large, it's a conjunction of many, many, many different problems, all of them hard to solve. So my name is José de Oliveira. I'm the lead engineer for the Autonomous Vehicles initiatives at Unity. And we're going to talk today about synthetic environments for development of autonomous vehicles. Is one of the many pieces necessary to crack this puzzle. So the agenda today, we're going to talk about a few things. We're going to start with a little bit of context. So this is autonomous vehicles is part of the automotive initiatives at Unity. So if you have seen a similar slide like this, those are broadly the 5 different areas that Unity is tackling on the automotive sector. All the way from product design, CAD, and all this, sales and marketing, services, training, HMI, and we are here. Right? So if you just joined this presentation, that's where we are in the world of automotive initiatives at Unity. So, but why simulate, right? That's not a straightforward answer. Some people are still struggling with the ideas that maybe to build autonomous vehicles, what they need to do is to put more cars in the streets. Sometimes the company or the person or whatever, they come from a hardware or an automotive background. And the easiest way to tackle the problem is just like, let's put more cars in the streets, let's collect more data, let's get this stuff work. Basically on the hardware alone, or primarily on the hardware. The problem is that the core of autonomous vehicles is software. And as a software problem, it has to be sorted out through software ways. So, and in the core of the software is machine learning. And machine learning is a very hungry technology, hungry for data, right? So collecting the data necessary for the machine learning as it stands today with the existing technology for machine learning is a very expensive process. Most of the models require a lot of data to be trained, a lot of data to avoid overfitting, a lot of tweaking. And for you to train, particularly if you're thinking about perception, computer vision, and things like that, annotating the data, meaning you need to give data, not only pictures that don't mean anything, you need to give pictures, and in the pictures you have to identify each one of the objects. And this process is both expensive and error-prone because it's done by hand, by definition. If you had a system that could identify in a picture each one of the elements, you'd have sorted the problem in itself. So it would be a reentrant problem, right? This is not a reentrant problem right now. You need to bootstrap that somehow. And I think one of the least understood problems, issues on collecting solidly data from real world is the fact that it only knows about what already has happened. And this is a good drawing, right? I like this picture. This picture is like, the worst is behind me. You've been through so many things. You have 500 cars running for 2 years in the street, and you think you've seen it all, right? I've seen it all. I mean, our algorithms are ready for anything, right? The worst is behind us, and in front of us is a smooth road until you bump into something like this. And I'll take you guys the time to figure out this. And shout out to the Russians Dashcam forum that I love, because some of those things, when you're going to see a tank crossing the streets in the snow, I don't know. It's just crazy. But you know, your car is going to have to deal with this kind of stuff if you want it to be fully autonomous, right? And most likely you're not going to pay someone to go in a cart, in a supermarket cart in the middle of the road just so you have data for that. I hope not. So in short, why simulate? Simulation can get the autonomous systems ready for unforeseen scenarios, edge conditions, in a fast and cost-effective way. So the fast and cost-effective way cannot be understated. Right? This is super important because this is, as I said, effectively a software problem. And as a software problem, there is a development cycle. There is a software development cycle that keeps on evolving. And broadly, maybe not everybody agrees exactly with each one of the steps here, but that's how typically I see that. You start with models, machine learning based or not. You have models, you have your algorithm that's going to control whatever systems in your car. Then you have to go through a phase of validation. If you're intending to put this car in the streets, you need to certify it. So the certification you can imagine as being a validation by an external organization, like a government or some sort of organization that's going to validate that your car is safe to go to the streets, right? And then you're going to do your real-world driving, and then you're going to collect data, and you're going to start the cycle all over again. Simulation and visualization of your data fits all these different parts. And it's important that you, as a development program, you try to get as close as possible to the concept of a continuous integration cycle, that you're evolving your algorithm, but you're evolving it fast, and you're evolving it in a safe way. And that's what simulation allows you to do. So with that, let's introduce a concept or name. We call that Unity SimVs. Let's go first to some definition, right? What is SimVs? SimVs is a concatenation of simulation and visualization, duh. But we put some alliteration for flair. It looks cool. In real terms, what it is a set of initiatives, features, and products that Unity is putting together to support simulation and visualization applications in the field of autonomous vehicles, primarily or initially, and beyond. That's what SimVis is. So from this point on, every time that you hear the term SimVis, that's what we are referring to. Is it a product? Yes, but no. Is it an initiative? Yes or no. Is it features? Yes or no. It's a conjunction of everything. Because the objective in the end is to get Unity as the best simulation visualization platform for those developing autonomous vehicles technology, right? So when you talk about simulation systems, where does it fit? We have basically two big pieces here. The first piece is the autonomous system itself. And that's typically how you represent the autonomous system in terms of subsystems. There's the control for the wheels, for the brakes, planning, also some people call navigation, or some people call all sorts of different names. But it's basically how you control your car through different situations. Then there's perception, computer vision, lidars, all sorts of sensors, sensor fusion, how you understand the world around you, and coordination, how this car handles other cars that are also smart cars, quote-unquote smart cars. This is the part that has a lot to do with what we call V2X, which is vehicle-to-everything communication. The point here is that autonomous cars can and should benefit from information that other autonomous cars collect, as well as the city infrastructure, right? So if that's the autonomous system, on the right side in purple, that's the simulation environment. And the simulation environment, we represent basically three main areas. One is the vehicle dynamics, which relates kind of directly to the controls. The environment, so the environment we are talking here, dynamic elements like other cars in the street, or static elements like the street itself, trees, anything that doesn't move, and parameters for this environment like weather, time of the day, all sorts of variations you can do. And finally, the sensor model, which is cameras in the computer vision case, or lidars, and all the other different systems. This is the part that Unity focused the most, and specifically the SimVis focus on these areas highlighted here. The vehicle dynamics, typically we co-simulate with other systems, so we use other systems that have physically accurate representation of the car model. But environment sensor models and the scenarios itself, which is the collection, or it's represented as a database, so it's a little biased towards defining scenarios as a collection of different scenes or different situations. But the reality is this could be a procedure-generated set of scenarios too. But those are the areas that SimVs focus the most. So far so good. We are aligned, right? By the way, we have Q&As in the end, but if you guys want to jump in and have a particular question that clarifies the slide, then just jump in. So with that in mind, let's think about how to answer that initial question, is how to effectively improve the efficiency of the brainpower, the efforts in the autonomous vehicles environment, development. And that's our roadmap. How Unity SimVs can help development. We think that there are three main areas that Unity can help very directly. One is doing more of the same, what has been successful forever in Unity, and which is the incentivize the development community. It's all about the development. It's a big problem. It's a humongous problem. Nobody's going to be able to solve that by itself. And we have an outstanding development community that we should be taking advantage of. Everybody should be taking advantage of. So this means with the community to ramp up the creation of environments, tools for simulations, all sorts of things that in the past got built, the ecosystem of tools built on Unity to help in other industries like games. We need a parallel one for simulations. So second point would be there are specific AV and machine learning related technologies that we are building into the platform. So there are areas in which the plain vanilla Unity, and plain vanilla is an overreaching here, is a super comprehensive tool. But there are things that are specific to the autonomous vehicles that need to be integrated into the platform to make it easier to develop the technology in this area. And in the end, it's not only the ecosystem of developers, it's also the ecosystem of companies and different initiatives that are working together to extend the platform and create the solutions in the end. So let's see some of those things. So the first thing is like reach out to developers. Here's a couple of examples. If you go to the asset store nowadays, there's already a pretty rich set of assets that you can download and you can start building your environment. They're kick-ass environments. Some of them are the same ones that were used for games before. Some of them have already been built in the past year or so with the role of creating specific environments for automotive areas. And there's a page in the asset store itself. There's a page that's curated with some of these assets. You guys should be able to find it and take a look at that. In terms of building up the platform, the three main areas of investment that we have, and you can imagine that as pillars, although probably you're looking at from the y-axis in Unity lingo. But there are three areas of investment. The first one and the most important is right now, time-based importance, is content. Is to make sure that those building simulations can have access to meaningful content to start building their simulation solutions. What does it mean? It means, in some cases, support to open formats that represent data that historically has been used by other simulation tools and now can be reused into autonomous vehicle simulation. The other one is the creation of pipelines, specific pipelines for data ingestion in simulation. Examples, when you are talking about creating environments, is it better to have a completely artificial scene or to have a scene that represents, an intersection downtown LA, crossing of a street with the other street. Which one is better? Both of them, right? There's nothing better than the other one. The different environments are going to be used for different applications. Whereas you most likely, for training your machine learning model, you're going to have to generate data that extrapolates the data you can find in the real world in real world scenarios, real world scenes, like intersections that have like 7, 8 different streets coming to the same point. All of this is important data to train your machine learning models. Most likely not existent in the real world, some of them, but important for you to generalize the machine learning understanding of the world around that. So for those, the synthetic data is super important. The artificial data, everything is synthetic. We are talking about synthetic data here, but the artificial scenes are important. But for certification, for instance, if you're going to have your car going downtown London, very likely you're going to have to prove to the organization, to the body in charge of certifying your algorithms that the car can go through Trafalgar Square in the middle of 6 o'clock crunch time and not have anything bad. So for that one, you need a scene that is not an artificial scene, a real world scene. And those different workflows in terms of generation of content require very different technology, very different partners, and both of them are very important for this area. Then there's dynamic element models, traffic, pedestrians, bicycles, all sorts of different things that you should have in your scene. And finally, all of that is great, but you have to start from some point. So we believe that giving a robust set of starting content so people can evolve from there is important. I'm going to talk a little bit more about that soon. The other part about sensors, so all this content needs to be consumed by your algorithms through the lenses of either a camera or a sensor like a LiDAR, a radar. So having a support to building these sensors in a way that they can take advantage of any of the other contents that we just described is important too. And that's the part where the Unity role as a platform is super important. We need to make sure that we disconnect the two workflows from the creation of the solutions in the AV, the creation of content in AV, in a way that those creating the solutions can have a plethora of content options to choose from. And likewise, those guys building content have a rich set of customers that could be consuming their content. So not only content and sensors is important, but that yellow edge between those two, it's super important to get it right. And then finally, integration, because your simulation doesn't run in itself, by itself. It's part of a process, a big process. So sometimes you need to interact with hardware. So the whole communication between your simulation and hardware to generate what we call the hardware in the loop, having an actual system that will be on board the car, reacting to the information that is receiving from the simulation, and then in a safe environment so that you can identify bugs even in the hardware or maybe in the integration between hardware and software. This is how important. That happens in real time, so definitely performance is important too. So have the Unity running as a component of a larger simulation system in a performant way is one of the tenets that we are working on. And then it's no secret to anyone that this industry relies heavily on Linux, so having a much better Linux or ever better, ever growing support to Linux as it's already happening in Unity, that's our goal too. I mean, we are good, we're gonna get even better. That's in the roadmap. And then finally, when we talk about integrating directly with machine learning tools, the clear case we have right now is ML agents, which is a kick-ass toolkit that the machine learning team creates that allows for all TensorFlow and all the Python-based frameworks used by machine learning development to integrate seamlessly with Unity. And this integration is crucial to build, to take advantage of all the simulation environment that we are building, right? So this is how the roadmap looks like right now. We have, this is the expected roadmap at this point. We're going to start by providing a few reference packages, what we call solution templates. That's going to come by the end of this year. Super important in robotics in general and in automotive is integration with ROS, which is a robotic protocol. It's very well supported in the community developing robotic solutions. Data exchange, support to standards that are specific to autonomous vehicles, content that is sensor ready, okay, that yellow edge between sensors and content, have that stuff formalized and standardized is important. All of this coming by Q3 next year. Then finally heading towards scalable deployment. I mean, one of the key things about simulations is that once you have everything in synthetic form, you can have many instances of those. You can squish the time you need to get to your point by having several instances of that running in parallel, multiple, massive amount of those. And we want to make this process as simple as possible for those using Unity. Right? That's coming by the end of next year. So talk about the robust ecosystem. This presentation is not complete if we do not do a shout out to all these different companies, all working in Unity. Some of them are building the entire solution. Some of them are building tools for the solution. Some of them are building content. All of them are awesome. They have been doing an excellent. The inside joke we have is that this slide is getting more and more crowded every time we go. The funny part is that it's not that only more companies are coming to Unity, is that we are getting the permission of those companies to actually mention them here, which is historically has been a common practice in this industry. Everybody's very secretive. I think that is a coming of age in a way that those companies are more happier to talk about what they are doing. They're having some very awesome breakthroughs. And by talking it out, I believe that we're going to be able to really have this technology evolving much faster. And Unity is here to help because as an open platform, we are all about having people interacting with each other, right? So announcements, right? So we have a few things to announce today other than we talked a little bit about the fundamentals of autonomous vehicles. We talked a little bit about the philosophy behind what Unity can help. The effective one fits in the initial phase of the roadmap, what we call the solution templates. We're going to be releasing by the end of the year a couple of templates. One package is the environment. So it's a few different asset packages that have urban scenes, suburban scenes, highway scenes, and it's going to be available to speed up. We believe it's going to be speeding up considerably the initial development of simulations for some companies, some people that want. And the other side of the templates is the sensor array. We're going to be providing an initial sensor array. Just a shout out, sorry. We partnered with Indigo to do these environments, the content environments. And for the sensors, we're partnering with CVidia. They have a product called SimCity. So this sensor array is called SimCity Lite. It's a lightweight version of the sensor arrays that they also produce. It's going to include the RGBD cameras, LiDAR, radar, IMU, which is the inertial movement, and GPS. This is a snapshot. The things get much more interesting when you put them in place. So sorry, the frame rate is not so good. That's the problem in how I recorded this. But that's how it looks like. It's a Unity. This is the environment, the solution template environment, plus the sensors running in unison. We have 2 LiDARs here and 1 RGBD camera. The hope is that it's going to be as simple as dropping instances of the LiDAR wherever you want. This is configurable. You're going to be able to configure the field of view, number of beings, frequency, and all sorts of little things. It does not represent a real model of a particular light or of a particular brand. That's not the goal. The goal here is to give a template so that people can develop out of that the specifics of the solutions that they want to do. And just early today came live the landing page specific to SimVs, unity.com/SimVs. You're going to be able to have access to quite a few articles, some content. And right here, there's a button if you are interested in getting those solution templates and early access to the solution templates. That's the place you should go to request that access. And we're going to get in touch with you guys. But there's more. So this presentation is completely based on the fact that Unity is a platform that helps people build their solutions. And we just happen to have some of these guys here. Tomorrow, Lumineers at 5 o'clock, they're going to show some of the cool things that they've been building with Unity. In the AutoTech booth, in the exhibition floor, we have MATLAB and Vector Zero with a couple of stands there showing very cool stuff. And with that, we're going to open for questions. If you guys have any. Sure.
Are the templates that you're releasing procedurally generated, or is it just a model?
So the question is if the templates we're going to release are procedurally generated. No, they are not procedurally generated. The environment contains things like traffic models and pedestrian models and things like that you can script and change properly, but they are static environments. They are. Hi.
Is SimVs going to take advantage of the new machine learning cores and the NVIDIA GPUs?
So the question is if SimVs is going to take advantage of the machine learning cores in NVIDIA CPUs and others. I'll give you a nuanced answer. So the cores help a lot in training your models. So definitely, if you are running simulation in Unity and you are training your models at the same time, for instance, if you're using machine learning agents, which helps you build something like a reinforcement learning, in which you are interacting with the environment at the same time, then you will be able to take advantage of those cores. I would say that arguably we're going to take more advantage of the real-time tracing capabilities coming, which is also common to the films and other areas, than actually the cores itself. For inference, let me say that this is a good question. So I'm thinking as I go. For inference, which means applying the algorithms to a particular problem, you might be able to take advantage of that too, in the sense that when you do an end-to-end simulation validation, so you have your whole car, you have all your model, you have your perception model, you have your sense of fusion, you have your navigation, and now you're going to be using simulation as a suite of tests to see if your car is passing these tests, then at that point, your car is effectively running as a living machine learning algorithm. And in that point, I think you can take advantage also of those cores. Thank you. Okay.
What are the resources that you're using in order to drive these simulations? Like, how much are you expecting to use per simulation on a server or data center? Because I assume this can be deployed broadly in many instances as opposed to just one at a time.
Okay, so the question is how many resources we are expecting to be using in each one of the simulation units. So I'll give you yet again a nuanced solution. When you're doing simulation for the effects of training perception, computer vision, the quality of the images, the realistic effects, it matters a lot. in this case, it's expected that each unit of simulation, let's call that a unit of simulation, will require quite a bit of resources of the machine itself to make sure that the sensors, particularly most of the sensors, sometimes the sensors are implemented as raycasting based things which can be computationally heavy. And if you want to have like 4 or 5 different LiDARs, all of them throwing casts and things like that, things can get really heavy at that point. For a simulation that tests out the policies or behaviors and navigations of the car, realistic rendering is not really a requirement. So the resources are actually pretty light. In either way, if you're thinking in terms of how we're going to be scaling out the simulations, it affects what kind of computational node you're going to be using. But that's the beauty of scaling out, is because if you get to a point and you have 15 LiDARs and your simulation is really not capable of running at real-time speeds, you really don't care. You can have your simulation running at 2-3 times, as long as it's not a hardware-in-the-loop scenario. If it's a completely software-in-the-loop, self-contained, you can have your simulation running 2, 3, 4 times slower than real-time, but then you throw 4 times the number of machines to run, and then you are back to quote-unquote real-world data levels. Does that make sense? You can compensate for the. Exactly. Thank you for the question. More questions? Hi.
Are you looking to integrate like computer vision libraries? Are you looking to integrate like MATLAB?
MATLAB. So the question is, are we looking to integrate with things like MATLAB? Yes. I mean, as a matter of fact, there is already integration with MATLAB in Unity. Companies do use, particularly if you remember that the architecture we put, which you have the control for the car and we have the vehicle dynamics. Lots of the vehicle dynamics these days are described in MATLAB, so it's already integrated. If we want to do a more standard way of integrating with MATLAB, that's a question that we are still checking. It's all about what's the cost benefit for the customers itself, and we're going to be choosing which one of the integrations we're going to prioritize as we go. Does that answer your question? You can talk. More questions? Hi. My favorite question. So the question is, any plans to include open scenario? So one thing that I didn't present maybe so detailed is this difference between scenes, which is these environments, and the actual scenarios, which is the variation of the elements in those particular scenes, right? I mentioned that a little bit, but I didn't. Sorry, it's just a preamble to the question itself. Within the scenarios, meaning if you're representing a car running an empty street or a car with several other cars around you, what's the position of these cars, etc. All of these are different scenarios. Open scenario is one of the formats. Right now, correct me if I'm wrong, I don't believe it's a very stable format yet, but we do intend to support it to the extent that it becomes something that it's a mainstream in the industry. How we are going to support it, I have some ideas. I have a dream. I think that an open scenario maps very nicely to some of the features that Unity already has around timeline. And I think that if we decide to support open scenario, I believe that the solution is going to be very, very nice. That's all I can say right now. More questions?
It's a very similar question that I had.
Sure.
But it's more from the open standards. So you talk a lot about open standards, but what we face today a challenge on making our simulation environments very catered
That's an excellent and complex question. So the question is, regarding the support of open standards, the reality of the industry right now is that some of the open standards are perceived to be subpar compared to some of the non-standard solutions that the company has been doing. Arguably, the existing fragmentation in the market is a consequence of the industry going forward in a neck-breaking pace, and the standards just not catching up with that, right? So we believe in open. Unity believe in open, and standards, typically open standards, are the best way to do that. More often than not, standards can come from the industry itself. So we are keeping an eye on initiatives. Baidu has an excellent initiative with Apollo. There is an initiative for open simulation interface in Europe, Pegasus project. So we are keeping an eye on those, and we are trying to identify those that the formats and protocols that might become de facto standards. And we're going to work with those companies to make sure that Unity support those that make sense. Philosophically, I think would be ideal if we could have very clear standards that people could rally behind. Yeah. More questions? Sure.
When it comes to validation of your sensor models, which you're planning to integrate with Unity, you pointed out that it's not a goal to do that to real life validation. So it's more out of the box machine learning activities. But thinking from the point of view of actually deploying them on the cars, you need to validate your sensor models against the production sensors available today. So how do you do that in terms of photorealism and how the sensors capture these objects?
So the question is about sensor validation. This is one of the biggest problems in simulation, is that when you model your sensor, how to know if the sensor is actually representing what the real world sensor is producing or not, right? So I didn't say that sensor validation is not something that we are looking for. There is a fine line here between what Unity can do and what the customer should be doing. We are not a hardware company in the sense that we are not building the simulation solutions, and we don't necessarily going to be, like you saw the solution templates we have, they are not specific to any model of sensors. And that's by definition, because the process of validating a sensor, we believe, should primarily come from the sensor manufacturer itself. The goal, if you saw the slide about the work roadmap in sensors, the ideal, if you ask me, would be that we have a platform with, that is open in the sense that it's programmable, so that the sensor manufacturers can create models that they can vouch for, and everybody else, either the guys building solutions or people maybe trying to buy those sensors, can actually use it to give it a try, give it a run. It doesn't mean that we're going to be completely out of the business of helping people validate the models. Another way of validating sensors is not necessarily to do the physical validation of the sensors, but to check if an algorithm using that sensor can, for instance, segment all the objects in a particular scene that the sensor would segment elsewhere. The ability of doing this side-by-side comparison, of course, we don't control the real-world collection of the data, but providing ways in the platform for people to collect the segmentation data from sensors that they are modeling and then doing some sort of a differential comparison in the results, that's something we want to work towards. Thanks for the question. Any more questions? Those are very good questions, guys. Some of them have to think. This is a big problem, and we rely on you. The reason why we're here in Unite talking to you guys, some of you guys are from automotive companies. Some of you guys are looking at this as a curiosity right now, and I'll make the claim, make it a task for you to jump in and see what you can help. There's a lot of work to be done in this area, and typically work maps into opportunity and opportunity to the business. I think this is an area that's a very good area for you guys to jump in if you haven't yet. With that, if you guys have more questions, I'm open to have questions after this session. Unless someone has a last minute question, I'd just like to thank you guys very much for being here.